is this one where you subtract. Let's try and see if he's right. If I were going to subtract them, then it would be x cubed, right? Okay, let's do it the long way and see if he's right. On the top one, I'd have 5 x's, and on the bottom one, I'd have 2, right? In a fraction, how do I know when I can cross something off? Anyone? How do I know in a fraction if I can cancel it out, cross it off?
But there's at least one of the same kind of thing.
It has to be the same thing. Good, on the top and bottom. So like, those are the same, so that reduces away, right? And those are the same, so correct. There's 3 left, it'd be x cubed. So notice how this one's real similar to our last one, right? So if I am dividing exponential terms with same base, subtract the exponents.
How would you do number 3 then?
We'll get there. Okay, number 2. Do I need to write out all the 5s 14 times?
Yeah,
Heck
do it.
no. And then I do 14 minus 9. You can if you want. But I like to be speedy. 5 to the 5th. And then just like on the last ones, you can go in and type 5 to the 5th in your calculator if you want. But it's an exponent day, so I don't care if you do or not. So do it the easy, lazy way. Okay, 3's weird, right? Because there's those numbers there. But just like on the last ones, you don't want to think about those numbers attached to the x because they're not. So do you see? I put in my invisible 1 and I put in my timesing dots just to help me visualize that they're separate. Does that make sense? Okay. These, the 6 and the 2, are those exactly the same? So I can't do anything with their exponents. So just pretend that's not there. How would I simplify 6 divided by 2? It'd be 3, right? You literally just divide it. If I asked you to simplify 6 divided by 2, it would be 3. But then these are the same base, so I can then subtract their exponents. So 3x cubed. Doing okay? Okay, let's do one more together and then I'll have you try a couple. Okay, write this one down somewhere in here. 5x, why is it so hard to think of a number when it doesn't matter? 4, great. Over 10x 10.
You couldn't just leave it 4?
I don't know. It's a long day. Okay? So first, I'm going to put in my timesing dots because it helps me split them up. Five and 10 are different, so I can't use my rule right here, but I can still simplify it. What is 5 over 10? 2? Close.
Half.
1/2. The 2 is on the bottom. Times x to the negative 6.
Could you just do 0.5?
Sure. 0.5 x to the negative 6 was good too. Where's the negative 6 come from? 4 minus 10. Perfect.
In this assignment, are we gonna like move it down and everything?
We do that next class period. Okay. If you don't know what he was talking about, it's okay. Pretend like you didn't hear it. It's next class period. Right now, we're just going to get the rules down, and then we'll deal with that, okay? Questions? Okay, let's, there's like none to practice of this one. Nice one, Summers. What am I doing wrong? Okay. Well, should we just do the next rule?
Yeah.
Okay, next rule. And then I'll have you practice a few more. Power of a power. This one, people always get confused with the top one. I like to think that the easiest way to tell the difference is like, look, there's only one X here, and on this one, there's two X's, okay? So this is when I've got two different exponential terms being multiplied together. This one is when I have one exponential term being raised to a second exponent, all right? So first, let's do the long way. So if I have x squared times itself 3 times, does that make sense that that's what this is saying? X squared times itself 3 different times, right? I just had to make sure I was still recording. Then, using our last rule, I could add those exponents, right? So how many total x's are there? 6. Okay. Did I need to write these out, or could I have gotten there from the beginning? Yeah, so that's what this rule is you can times the exponents. So if I have an exponential term, raised to another power, that's a fancy sentence, isn't it? Then you multiply the exponents. That's the tricky part. You multiply the exponents, not the base, the exponents. Okay, the second example is why I put that in caps and underlined it a bunch of times. Is 2, the one in the parentheses, is that an exponent? No, I'm not doing 2 times 2. I'm going to be doing 2 times 1. So it'd be 2, 1 times 2, and x 4 times 2. So notice on this one, I could just times them, and I'm doing that here, but the 2 is multiplied by all exponents in the parentheses. All of the exponents in the parentheses. We're going to do more of that, okay? You guys see where'd the 1 come from? It was the invisible exponent, right? Okay. So then my answer on this one is 2 squared x to the 8th. I actually want to jump to the 4th example first on this one. What's the exponent on the 2 right now? Should I times it by 3? I did on the last one. Very good. On this one, the 2 is not in the parentheses, so it doesn't get multiplied by the 3. This one, the 2 was in the parentheses. That's why I had to multiply its exponent by the 2. That's what you want to watch for. Parentheses. You guys with me? Okay. Well, I'll find out when I have you do some examples in a second. Okay, on this 3rd example, don't forget your PEMDAS, okay? Before I can deal with that exponent of 4, I have to simplify inside the parentheses first, right? So inside those parentheses, if I put my times signs in between, now once you get good at this, you may not have to put your times signs in, but I just like to do it at first because it helps me visualize that those aren't stuck together, okay? So what I can simplify in the parentheses is putting my numbers together. So it's 6 times x times y to the 4th. hopefully you guys will start seeing that you don't necessarily have to write all these steps down once you get good at it. Okay? So all I did is the P in PEMDAS, parentheses, all I did is multiply the 2 and the 3 together, okay? I don't see any exponents on those. So what are they if they're invisible? Are they 0? Well, they're 1. So now I'll multiply the exponent by 4, not the 6. 24 shouldn't be in there at all. 6 times 4 is not something we're doing. It's 1 times 4. So 6 to the 4th, x to the 4th, y to the 4th. Is 6 to the 4th 24? No, it's way bigger. It's like in the thousands. Actually, I have no idea. 36, 216 times 4.
1,296.
Yeah, in the thousands. That's what I said. Okay. Yeah, I'm always right. Just ask all my boyfriends. Just kidding. just seeing who's listening. Okay, you guys ready to try some? Or do you want to get the last rule done? Let's try some. I think we should try some.